Hey, so here's a part two of this outboard conversion that I'm converting to run off a BLDC, well, DC electric motor. It's a brushless motor. Uh, Vivor, they are not the manufacturers of the motor. They just slap their sticker on and they resell it. So got the motor mounted. You can see the bracket I made. The bracket's pretty simple. You've got two angles. They mount to where the existing motor mounted. The middle piece may or may not need, I needed that to keep it from flexing while I welded it. I welded a 3/8 inch plate on there, and the motor is mounted onto the plate. Just kind of ran a MIG weld on there. It came out pretty nice. As you can see, the motor's mounted. So here's all the technical details. How did I mount the motor to the existing drive shaft? So my first attempt was making a coupler, and it actually worked. This was just a theory to see if it worked or not. I drilled out the coupler on both sides. There are two different sizes. Obviously, the motor is a metric size and the shaft coming up as a ANSI standard size. I'll give you, drew up a little diagram. So let's see what's going on. So the motor actually has a reverse thread on it. It's an M8 1.0 pitch reverse thread. It's a left-hand thread. I was going to use it, but I realized I can't because I had to reverse the rotation in the motor. When I did, I had to come up with a different idea. So what you see in red is the aluminum coupler. My initial coupler was only 2 inches long, and the size of the coupler was too small, and I screwed up in the hole. It vibrated way too much. So the new coupler, actually, you can see it runs all the way up to the base of the motor. So it grabs the shoulder on the inside and the outside. And what prevents the coupler from turning are set screws. There's a set screw on both sides. The drive shaft coming out of the motor has the same thing. There's a set screw on both sides. There's a shoulder for it to grab. The new coupler I made had to be an interference fit. That means I had to tap it on to grab both shoulders because the initial run was vibrating way too much. So that is a coupler that's on there right now. So as you can see, if I pull the motor off, there's a coupler, there's the two set screws. You can see how close that is. Obviously I had to drill out. I don't have a lathe. I wish I did. It would have been smoother, so hence the coupler being a little bit longer. And the reason for this was so if I needed to drop the lower end, I can just pull two set screws right there, and the lower end drops just like a normal outboard. How did I drill it? Well, my neighbor gave me a pretty neat set of drills. These are Matco's, and pretty neat. Lots of sizes on them, self-centering, steel drill bits. Again, this was the original coupler. Too short, the hole was just a tad too big, and it vibrated. It ran. How am I going to run this? Well, let's see, the control box is here. There's a throttle there. It's a bicycle handle throttle with a key. That's kind of neat. Like I said, I've already run the motor. Plan is to sleeve it and have the throttle over here as it should be, and I'm going to utilize the existing holes in the front for a kill switch and a speed switch. Here's the neat thing about this motor is it has a high, low, medium switch you can just use a single pole double throw switch with. Quick dirty diagram. So control box, the two lines you see here in the red squiggly, that's going to be the emergency kill switch, basically an outboard kill switch. This line will be the brake line. So if you're applying the brakes on your bicycle, it'll kill the motor. That's the idea. A high-low speed switch will be added. And then here's the neat part. So this is the controller for the motor. Normally it's just tapped in with a throttle, and that's fine if you're in a motor with it, but if you want to troll with it, there'll be a switch in here to run a potentiometer. The potentiometer will just piggyback off the controller switch. Initial testing with this motor, low speed, it's only pulling 6 amps. Medium, 12. High, obviously it'll be 30. But hopefully The next video you'll see will be this motor running. And again, once I get it up and running, I will take it apart, clean it up, degrease it, paint it. It's just, again, simple, 2 angles, 1.5 inch angles, and they're about 3/16 thick. The plate up here is 3/8. That's all I had. I wish I had a 1/4 inch plate, but I'm fresh out. And if you pull the motor, you can see the mounting holes. The motor slips right in. There will be a rubber bushing between the motor and this mounting plate to quell any vibrations. I will have to cut the top off. This motor does not have a fan. I'm kind of disappointed, so I did have to enlarge the cooling holes, and I will be adding some sort of forced cooling, either a fan or something to blow air through it. Questions, comments, let me know.